We worked on another one of these Kaykraft archtops recently. It was a lesser model and it didn't have a steel reinforcement in the neck. I should mention also when this steel bar came out, it looks like it had probably been glued at some point in the past, but the glue had just sort of disintegrated, so that's why the bar came out so easily. What we did on the other neck that we worked on is we put in an adjustable truss rod, and we had to route out this channel, but as luck would have it, this channel is exactly the thickness we need it to be for this truss rod. I can't really shove it in there right now because the end is not open yet, but I had this truss rod made to a custom length at Allied Luthery, and at the opposite end from where the adjustment nut is, there's a little T-piece welded on, and the reason that they do that is you just notch out the neck right where that T-piece is, and it keeps the end of the truss rod from pushing down on the bottom of the channel. So if your neck gets really thin, it distributes the load across this T-piece rather than right at the bottom of the rod. So what I'm going to do now is notch out the mahogany neck to accommodate that T-piece, and then just extend this channel with a saw so that the adjustment nut lies just inside of this groove on the end of the neck. Alright, that side's good. Not quite deep enough, but just about. Okay, I got this end below the surface of the neck, and this end is just fine. So the neck is done and ready to go. So the way this works, it's a double action rod. So when you tighten the nut, it causes this upper bar to bow upward. So that puts, obviously when it's glued in place, when the fretboard is glued on, that upward movement of the bar pushes the peg head end of the neck downward. which is what you generally need in order to counteract the string tension. If something weird is going on and you actually have a bow in the middle of the neck, an upward bow, you can turn this rod in the other direction and cause the bar to move downward instead of upward, and that would correct an upward bow in the neck. Not very common for that to happen, but it is possible. So anyway, there we are. We're working on the fretboard for the K. Somebody in the past had damaged a lot of the clay dot position markers. They had also replaced some of them with mother of pearl. So we took out the rest of the clay dots and put in pearl dots everywhere. The binding along the fretboard was kind of a problem. This probably won't show up, but where every fret was, the binding was kind of sticking out due to years of the frets being proud of the edge of the fretboard.
Right, fretboard shrunk.
The fretboard shrunk after the guitar was built, so if you looked at it from the edges like this, it was like a scalloped binding in the wrong direction. So we decided, in order to make it look better, that we would just take all the binding off. We first tried pressing it, like, you know, right in position. We tried to press it back into shape, but it never really cooperated with us. So it seemed like the best recourse was to just replace all the binding, and that's what we have started doing. There, that's actually the right spot for it. So that's how the binding was looking, and you can actually feel the lumps from the outside. It's not just that the inner surface was compressed. So what's next, Jeff?
Well, we're repairing some chips. When we pulled the frets, the surface of the fingerboard is very friable, and so it's really prone to chipping. So what we did is we used a utility knife and ran the utility knife on either side of the fret before we started pulling it to reduce the likelihood of chipping. And it actually did quite a good job, but inevitably there's going to be some chipping that goes on. So right now we're in the process of repairing some of those chips to see if we can minimize the divots in the fingerboard. And then once we're done doing that, we're going to clean out the grooves for the new frets, and probably do a little bit of surface sanding, and we need to put the new bindings on. And there's a lip here along the edge of the fingerboard. I don't know if you can see that.
A curious thing.
Yeah, right.
Hold it up this way.
Sure. I can see it.
Yeah. There, I think that shows the lip.
So it looks like what they did is they actually routed, or whatever the process was in the day. I suspect it was routing. They routed this little ledge into place, and then the binding sits on top of it. Well, there's a little place where that...
So you can show that that's obviously not the right binding material.
But you can see there's that little ledge there. So unfortunately, a little bit of the ledge was non-salvageable. So we've cleaned that up and surfaced it. So once we get the new binding on, then we'll glue a little piece of wood along the edge here to finish that ledge along the side of the fingerboard, and then refret. Yes?
After we glue it onto the neck, we'll refret, because I want to get the fretboard glued on and make sure it's perfectly level with the neck, and then put in the frets.
Makes sense to me. So that's where we're at.
Rightio.